this up. Let's come on over here. Okay, shall we do the ends first like we often do? Do the ends? Yes, so what's the chance I got all roosters? What's the chance I got all roosters? Be brave, my friends.
0, 0, 1.
Yep. If I got all roosters, that means I had to get Max to reach into that bin, or all those bins, 4 different times, and each time get unlucky enough to grab a boy. Now, I'm calling this unlucky because I want girls, right? So getting 4 boys would be very, very bad for us raising eggs. Fortunately, what's the chance of that actually happening? 1 in 10,000. It's going to happen 1 in 10,000 times. So in other words, if I send Max into that store over the course of 10,000 years, once a year, in one of those 10,000 trips, he'll walk out with 4 roosters. You see what I'm saying? It's completely ridiculous, but it's an exaggerated form of what? Beth from Whack 405. Over time. Over time, 1 in 10,000. Which means in 1 in 10,000 trips into the store. Think about that. That probably never happened, even in the course of a year in this store. Right? It probably never happens, because I doubt very much there are 10,000 trips in the entire state of Oregon to a farm store to buy chicks over the course of a given year. Make sense? Tabitha, go ahead.
Did you get a refund if you get a rooster?
I don't think so. I don't think they did. I think you just stuck with a rooster. Look at Craigslist every once in a while. They're always giving away roosters on Craigslist because they're the ones that have these. Well, hold that thought. Hold that thought. Well, you can, but some people don't want to kill them. They want. I mean, I would make soup out of them, but but don't name them. As soon as I named them, we were screwed. Because we named them before we knew they were girls. And then Nancy just be the rooster that's Nancy, and I couldn't kill her then. It's like killing your grandmother. You go to hell for that, right? Anyway, let's go down to here. This is what I calculated kind of quickly in my head that night at the store. So what's the chance they're all girls? Well, on the same logic, it's 0.9 right across, correct? Yeah. So what I did in the store was I couldn't do that in my head. I couldn't get the precision that Tabitha got. So I did 0.9 times 0.9, which is 0.81, and I called it 0.8. And then 0.8 times 0.8 is 0.64, which is 2/3-ish. And that's where my 1/3 came from. Does that make sense? So, but Tabitha, you got us much more precision. 6.561, correct? Yeah. So you see, it's exponentially harder to get all boys, but it's also exponentially harder to get all girls. As a matter of fact, if you buy enough birds, eventually it's going to be very, very hard to get all girls, isn't it? Because every time you buy another bird, it's 0.9 less likely. 0.9. It's exponential modeling from 105 again. You take 0.9 or 0.9 or 0.9. Eventually it's going to drop down below 20%, below 10%. You buy 100 birds, 0.9 to the 100th power, it's effectively 0. Which means you got some boys in that deck, and you got some boys in that batch. You've got enough of the population in your sample, if you will. You've got enough of the population in your sample to start seeing the other side of the binomial. Cool!
Can I?
Yes, Raphael, go ahead.
Do you mind if I use my stuff from my last math process?
No.
Put that in as a slope?
No, this is a beautiful slope, man.
Yeah.
That's a beautiful, binomial is a perfect slope. Unchanging slope.
Yeah.
Please.
It's going to be a linear.
Do I mind crossover? Not at all, brother. That's why I speak Delaware and Oregon.
Yeah.
How about 1 girl and 3 boys? What's that going to look like? See if this agrees with you guys. You have something like that?
Mm-hmm.
But what else do you have? You got times of 4, don't you? Yeah. Because in order to have the one girl can be either Marge or Mary or Nancy or Bertha. So you got to have 4 there. And that's going to be what, 0.0036, if I'm doing that math correctly? Is that likely to happen? Is that likely to happen? Not according to that. That happens less than 1% of the time. So again, like this is very unlikely. Using our outlier rules, unusual events. Unusual events. Did you come down to this one next, I'm assuming? This 3? Yeah. It's easier to go back and forth like this. Okay, so this one's going to look like this one, except you only have 1 boy, and you got 3 girls, right? 0.9, 0.9, 0.9. What number's out front, friends? It's still got to be 4, doesn't it? It still has to be 4 out here. It still has to be 4 out there because there's now 4 different places for the boy to be. Either Bertha's the boy, or Mary's the boy, or Marge is the boy, or Nancy's the boy. So you got 0.9, 0.9, 0.9 with cheat. That's 729. 0.0729 times 4. 2998. 16, damn it, thank you. 2916? Yeah. Is that rare? Is that rare? Is that rare? Would you? It's less rare than the others. Would you call that unusually rare? I wouldn't either. It satisfies the outlier rule. It's not below 5%. It basically happens 30% of the time. Which means, think of it this way. Think of it this way. If I send 10 little toe-headed 4-year-olds into the store to buy 4 birds each, in 3 of those 10, they're going to have a rooster and 3 girls. That's what that tells me. On average, that's what that tells me. That's pretty common. 1 in 10,000 versus 3 in 10. That's a huge difference, right? Almost never happens. Almost guaranteed to happen. It's still less likely than this. This is still the most likely. But these together account for 95% of what's going to happen, right? Yeah. Now, knowing those 4, you can calculate what goes here, can't you? You can calculate this. But can you also build it? 0.1, I think it's going to be 2 0.1s, right? And then 2 0.9s. What's the multiplier? 4. It's more than 4.
Oh, really?
It is. Say that again. 8. It's less than 8. Let's figure it out. Go to the birds.
Is it fox?
It's let's figure it out. Let's figure it out. Let's figure it out. Let's figure it out. Let's count them. Okay, there are the girls. Drop this down a little bit here. There we go. Okay. Let's pick the 2 that are boys. It doesn't matter if we pick the boys or the girls because it's 2 and 2, right? Who can be boys? Well, let's pick it. Let's be organized. Which 2? Top 2. That's one way.
Bottom 2.
Bottom 2.
Left side to the left.
Left 2.
The right.
Right 2.
Diagonally.
Diagonal 2.
Other diagonal.
Diagonal 2.
No more.
Well, that's it. That's because there's no way to do it. There's 6 ways for it to happen. There's 6 ways. This is why I said, remember how I said how Bertha and Mary hang out together? I think that's unusual. That doesn't happen because there's 6 different ways for these chickens to pair themselves off. So it's interesting that those 2 kind of pair themselves off. So there's 6 ways for it to happen. Now, some of you are sitting at your desk going, I don't want to know that. Because what if there were 100 chicks instead of 4? Or even 10 for that matter, instead of 4. Well, the good news is I just gave you that program for a reason. The program takes care of all that for you. It keeps track of all these beautiful districts. I'll show you in a moment. I'll show you in a moment how to actually use that. And what does this come out to be? Let's see. That's 81. 0.0486. Is that right?
Yes, 0.048.
Yeah. Okay. I can do multiplications. Okay, good. And that's nice. That sums to 100, doesn't it? That actually will sum to 100. Now you would know right away that 4 was wrong. If you did 4 times all this, that would be too small. That would be too small. And so you know something was up. Then you'd have to kind of guess and check and think it was 6. Or not. I don't want you guessing and checking if it was 6. I don't want you dealing. Although these binomial coefficients are gorgeous and they're fun to figure out, I think you guys have already figured out how to find this one. Well, first of all, you know that these are 1s, don't you? Those are always 1, because there's only 1 for it to happen. You know that this one has to match however many items you have. And so does this one. It's the ones in the middle that are the challenge. And rather than teach it to you in class, which you'll probably forget, I'm going to put an optional quiz up that kind of walks you through it, if you're interested in how to come up with those. If you're not interested, and I don't expect you to be, honestly, I don't expect you to really care where they come from. That's why I just gave you the program I gave you. Take a look at that real quick. I know we're almost out of time. But I want to walk you through the beauty of that program here real quick. And we're going to walk through it again on Wednesday, of course, after your exam. But check this out. Turn the computer off. Over to the document camera. There we go. Okay, fire her up. Where I just placed this stuff is under the program button, which is right under stats here. Program's right under it. I've got a lot more crap. You find the one that's called dist fill. Probably number 2 on yours, I'm guessing. Run it by pressing enter. We'll do lots more of these on Wednesday, I promise. It asks for the smallest and largest x values in your distribution. So you have to at least have the distribution started. Our smallest value is 0. And our largest value in this case is 4. So 0 to 4. Okay? Then it asks you, what kind of distribution should L2 be? It doesn't divide over the sign, exactly. I know we haven't much formally defined what that is, but you're getting a feel for rooster, hen. Rooster, hen. There's two things, binomial. So go ahead and grab binomial, okay? It asks for the probability. You have to have that binomial probability given to you. In this case, every bit of this was built off of 0.9, wasn't it? Every bit of this was built off of 0.9. You think about that. All of this came from knowing your 90% early. Pretty amazing if you think about it. 0.9, okay, you ready? It says done. Go and look at your stat lists. There's your distribution, right there. It fills the lists for you. It fills, it does all that coefficient work for you and fills it in. Your TI actually has this built in. We'll show you yours, Mike, in a second. But the TI uses TIEs, which I can't stand. This puts it in English for you. Make it binomial, fill L2. I mean, stuff, language like we use in class. That's why I wrote the program. Makes it more class-like. Okie doke? That's the beginning of the binomial. More on Wednesday after your exam. After you kick ass on the exam, I should say. After the exam, a new one. Just saying. I'm saying. That's all I'm saying. That's all I'm saying. Okay, email me if you guys get stuff. If you're looking over anything.